So now we will move on to Emma's talk, who will be talking also about types runtime validations in TypeScript. So Emma, it's nice to have you on.
Hello, everybody. Thank you for having me here. It's a pleasure to be in this meetup. Besides, we are both in Berlin. We're doing remotely because of Corona, but still very happy to be here.
Great. You ready to give your talk?
Yeah. Can you see my screen and hear me well?
Okay. Yes.
Perfect. Perfect. So then start. As I said before, hello, everybody. Pleasure to be here. The name of my talk is Runtime Types Validation in TypeScript. But first, let me introduce myself. Hello there, I'm Emanuel Suriano. I'm a web developer and open source enthusiast. I have some open source project there on GitHub, so you can check them. I'm also a tech writer, and also I have another non-tech blog, which is like I write about random stuff. For example, I've been writing lately about Corona situation. One of my hobbies is I'm a big fan of cooking, and also that involves eating and traveler. Yeah, big fan of that. As you can see here, this is a picture of myself when I was in Thailand, one of my best trips. And by the way, the food there is one of the best things I ever tried. So let's start with the talk. I've been working in this past around 2 years with TypeScript and different project size. And I just grouped up some of the quotes that I normally see coming up. This is the first one. My application is fully typed. It's 100% bug-free. Let's see. If it builds, it will work in production. That's a very good one. And the last one is we're using Tyscript. There is no need for test or to test. And I don't know about you guys, but my reaction is always like, why this is happening to me? Why people are reluctant, for example, of testing? And here's why. It's a very simple scenario. So this code is actually the build of Tyscript will pass, but we will see why it will actually explode in your face when you run it in production. So let's say that we have this example type here, which is a type with name, which is a required string, age is an optional number, and pets, there is a required array with name and legs, string and number, both are required. Then we have this function, which is fetch data, which is a promise that returns an object with this type. There is no need to code it, just we say that we're returning. Then we are fetching the data inside this function, which is getBy, who ideally will return the pets that has 2 legs. So what happens if our server returns this type of object? TypeScript will actually doesn't know what this will happen in production, so ideally it will build successfully. But in reality, once we execute this code right here, as pets is undefined and fine is not can be fine inside undefined, so this will explode. So yeah, I guess that many of the people in this meetup already know this, but TypeScript performs static type checking. Runtime validation are outside the scope. So it's actually on the developer side to make them. But then do I need to validate absolutely everything? So the question is no. As a general rule of thumb, I like to say that validate all the external sources of your application. What do I mean with that? For example, API responses. Every time you have an API, it's always a good practice to type them to say what is my expected structure, but also validate the content, so you don't have the problem that I just showed to you before. The next one is content inside files. Let's say that you're reading from a file that you expect to have a specific JSON structure. So again, it's a good thing to type your structures, but also validate them, because it's quite easy to just change them, and then inside your code, everything will be fine in your build, but in runtime will fail. And the last thing is untyped libraries. So nowadays, if you are using some library that is well-known, it will most probably come with a type definition. But sometimes, if we rely on some old libraries, they don't have them, we can type them also is a good practice, but even though, like, if we are not 100% sure that the result will always be that type, we should at least validate them, just the core part. Okay, so let's see some of the commonly used approach to fix this problem. The first one, and is the one that most people go with, is the manual validation, which is a set of conditions that check if a structure is the expected one. So this is what it looks at manual validation. It's just a JavaScript file which will take our example type or expected example type, and then we'll basically check that bet exists. And then here you can do more checks in case you want to. And then basically, if everything is good, then you return true, otherwise you return false. Inside your main function, here's the same examples that showed before. We are just getting the data the same way, and then we are just calling the function with the validate. In case it doesn't work, then we can say validation error, property not found. And the thing with throwing an error here is that we can catch it and perform better approach or better error handling on the higher level. And at this point, we know that our data, at least given this validation that we wrote before, like, are compliance with my type. So pros about this is, well, the first one is doesn't need any external library. This is just vanilla TypeScript or vanilla JavaScript. And the other thing is business focus. What I mean with that is basically you can check some properties that are by some reason inside the business logic link. For example, maybe property A shouldn't be present when property B is there or something like that. Given that it's a function and you can change it the way you like to, you can add this business logic inside. But the cons is, first of all, it's a manual work. Basically, they're handmade written functions, so you need to take care of that. And then the second one is that you're duplicating the code, because here you're saying that inside your example type, in your definition type, there is a pets array that is going to have name and you're going to have legs. And here you're saying, okay, data has a pet. And actually here we are not even checking for name and legs in case we want to like do it really strict. So I would say the more you validate your structure, the more you're going to repeat yourself. So as we know, that's pretty bad. Then we go to the next approach, validation library. This is basically make use of existing validation libraries out there to check for the structure. So inside JavaScript, there's like many validation libraries. To just summarize them, or I just make a quick search on Google, what are the most used and the one I used in the past. The first one is AGV, Joy by Happy, V8N, and the last one is validate.js. In this example, I'm going to show one simple snippet of AGB. Sorry for turbulence, my God. In this case, we are just recording AGB, then we are creating an instance. In the case of AGB, it exposes a function that is called compile. Here, I'm going to define my schema that is going to represent my kind of TypeScript validations that I want to apply on. So in this case, I'm saying that name is a type string, which has to have a minimum length of 3. So this is one of the cool things about use or relying on a validation library. So normally they have helpers that will allow us to check more than if the property is there or not. And yeah, which is pretty handy. Then I'm saying that there is an age of type number, pets, which is an array with these items, like the items has this structure. And then on the last part, I'm saying, okay, name and pets are required properties. Then my main function will look like something like this. This is more or less the same. Data, await fetch data. This is going to return, as we saw before, this structure. And then we're going to call validate. This function, this compile function, obviously returns a function that we can send an object, and then it will check all these properties exist in the pass object. So if this validate function return false, we're going to throw an error saying validation fail. And then as another advantage of relaying an library is that now we're going to be able to have formatted error messages or like better error management. So in this case, the validate function also contains the errors inside the object, and then we can format them. So this will be the message, the output message, error validation fail, data should have required property pets, which is pretty developer friendly, or at least it's not just a bunch of lines that you need to follow the code. And yeah, the same way, at this point, we are sure that our data belongs to the type that we assume that it is. So some pros and cons. The pros is it provides a standardized way to create validators and checks. What I mean with that is here we are saying, okay, this object has a name, and this name is a string, and then it also has a minimum length of 3. If you relay in the manual validation, there's several ways that you can do that in JavaScript or even in Tyscript. By relaying on a library, there is only one way. And this is great when it comes to developer collaborations. And yeah, it's always good to have that. The second thing is improvements of error reporting, as I explained in the part of the snippet. Basically, you don't need to, in the previous example of manual validation, we were just returning false, which actually doesn't tell us why the object is not the same as what we're expecting. We can obviously improve it, but that involves more manual work. So in this case, error reporting is out of the box just by using the library. As a cons, well, it introduced a new syntax. I don't know what you think of, but this object syntax, I'm not a really big fan. That is a type was actually quite simple, and the amount of lines to define the schema was quite a lot. So yeah, and obviously introducing a new syntax inside the project requires more knowledge about it, and it increases the complexity. And then the other one is validator and types are not in sync. And what I mean is, let's say that in our example type, we decided that pets is not anymore required. It's just optional, right? So then I need to basically come here to this schema and remove the pets from here. And the same goes with any other property. And I decided to put here Starble specifically because there are some ways that you can generate the TypeScript types from your, in this case, HTTP validators. So the community built some tools around it, but still, you have the cons of introducing the new syntax. So after seeing this example, let's see the approach that I want to show to you. It's called Dynamic Types Validator. And the main idea is that you create validators from your types. And if you compare what we did before, or how it was before in the past 2 examples, we have the validator from one side, and then we have the types in another side. The validator obviously validates the objects, and then the types belong to the objects, or at least is what we are expecting to. And then in the end, when we both combine this, we're going to have a validated type object. As we saw in the previous cons, validator and type sometimes are like separated. They can be together. There are some workarounds that you can do, but most of the cases they are like isolated. In the approach that I want to show to you, the types are going to generate the validator. Then the validator is going to validate the object, and in the end result will be the same, which is going to be a validated type object. So I want to introduce to you a tool that I found. It's an open source library. It's called Tyscript JSON Validator. And the promise or the description of it is you can automatically generate a validator using JSON schema and AGV for any TypeScript type. And I want to give a huge shout out to Forbes Lindesai for building this tool. I didn't build it. I just found it out there. And I think it's amazing. More people should use it. if in case you are using the TypeScript project. And let's see how it works. So let's say that we have our example type in this specific file path. So our type has a name with string, age optional with number, pets, which is an array with name and legs, string and number, and both require. So this tool is actually a CLI that you can call actually with npx if you want to. And then you need to specify two things. The first one is where, like which file this tool needs to look at. And then the second is the type that you want to create the validator from. So after you run it, this tool is going to generate a new file with the section .validator, and it's going to look something like this. So there's no need to go line by line because actually this file is generated automatically by the tool. But let's go just to the important highlights. So as the promise says before, this tool relates on AGB. So it's more or less quite similar to what we did in the library example. So here we are requiring AGB. Here we are creating the instance with some default values. Then, as you can see here, the type schema is being automatically generated for us, given what we have here. So this is very cool, which means that we can use TypeScript definition, and then they are converting into, in this case, AGB schemas, which save us a ton of time. And actually, if you take a look, this schema is better than the one I made by hand. So one difference is like I totally miss the required fields for items. I just said that legs and names are type, number, and type string. I didn't mention that they were required. So yeah, amazing that the schema is going to be automatically generated. And then the last thing is going to expose a validate function. So this validate function is something that similar that we did before. It's going to take a value with the type of known, which is actually more accurate than saying that it's example type. And then it's going to check, okay, is my value example type? And this function is here. And the only thing it's going to do is compile our schema. And then with the schema already compiled, it's going to pass the value. If this is true, it's going to return the value. And then this value is going to belong to the specific type, which is very nice. And then in case this throws like this is not true, it will automatically throw an error, more or less similar to what we were doing before, which is getting all the errors from the validate function. So yeah. And then how you use it, actually, it's quite straightforward. You just need to import it because we are importing the export default function. And then we are calling the validate function given the input from the promise in this case. And there is no need to add an if, because if you look at the snippet, the if is already here. So actually, the way that the code looks is, I would say, it's cleaner. So yeah, next step. One of the cool things is about this tool is it's integrated with AGB. So you can create this kind of mix between TypeScript annotation and AGB properties. And it will not collapse between together, because as you can see here, this is the AGB annotations, and well, there are comments. So it's not going to interfere with TypeScript. And basically what you can do is say which properties will be taken care or consider inside the schema for AGB. So email, it's an optional string, right? Which is here. And then we can define that also we'll have this format of email. The same for answer. Answer is a type number, but also we are saying that the maximum number will be 100 and the minimum will be 0. So this saves a lot of time. And the only thing that we need to do is add this annotation. Now we are having a way better validation way of working. So wait for a second. This means that every time we run our program or application, we need to create these files again and again. And yeah, that's true. But if you think about it, well, we are kind of doing that with Tyscript. But by the way, in order to fix this problem, it's not very that complicated. We just need to add a pre-build step. And in a very simple way, is that the pre-build step is one script that you add into your package.json or wherever you want to that needs to be executed before your application starts. So we are just calling TypeScript JSON validator with the same script that we saw before. So if we make sure that this script is always executed before our application starts, we can 100% say that this validator will be always be there. Another cool thing that I would like to recommend you, or I think it's a better way of working, is that these validator files can be actually excluded from your project, from your git ignore, because they basically are being generated every time you execute them. And in case you change your types, they should be always like renovated. And yeah, in case you want to commit them, you can commit them. But in case you change your files, you're going to commit 2 files instead of 1. So yeah, it's up to you. But I recommend that to ignore them, and you will save a ton of file committing to your repo. Because the bigger your types are, this schema will be longer. So just take that into consideration. So my experience with this approach, I actually used this approach in one of my open source projects. The name is Gatsby Started LinkedIn Resume. So in summary, it's a tool that you can use to generate your resume in HTML and PDF format from your LinkedIn information and with Gatsby. So it uses these tools. So the first one is Gatsby in order to create a static website. Then JSON Resume, which is a tool that will take the data and then a template name, and with that generate an HTML and a PDF file. And then the last thing is LinkedIn, but I didn't use the LinkedIn Developers API because there is a lot of bureaucracy in order to get access to all your information. So I just decided to go for a, I would say, different approach and use a crawler. But the crawler, to be honest, does the job. So this is more or less, in a nutshell, what the flow does. So the application or the starter has 2 main commands. One is build, and the other one is generate resume. So let's start with build. Once you start a build, you will ask the first question. Okay, is the resume data exist? If the resume data doesn't exist, you will need to jump into generate first your resume data, because obviously I can't generate your resume. If it is exists, then we can easily generate HTML and PDF for you. Once we go to generate resume, we are going to make the same question. Is the LinkedIn data there in your local machine? So if it's not, then we're going to ask for the LinkedIn credentials. Then we're going to call the crawler. At this point, we're going to save this LinkedIn data in your file, in your local machine. And the main reason of that is because the crawler can take some time, and is actually, sometimes maybe you want to tweak your LinkedIn information a little bit, and it's handy to have a file there. After that, we're going to map it between the LinkedIn structure and the JSON resume structure, and then we're going to save it. So after saving it, you can go to build, and then you will be able to generate your resume. So remember that I said before what things should be validated, and I said external sources. So in this scenario, what are my external sources? So the first one is the data coming from the LinkedIn crawler. I can type my LinkedIn structure crawler response like the best way ever, but there is no guarantee that the crawler will always return that information. So I must validate it. And then the other one is the local file with the resume information. So when you look at this structure, there is no guarantee that here the guy actually didn't create a file and manually change the content of the resume the JSON structure. So it is a good practice if I validate it. Like if you think about it, it's a file with the JSON structure that I need to validate in order to make it work with another tool. So yeah. And these are both the relevant types for these scenarios. So the first one is the LinkedIn schema. And in a nutshell, this is the structure of the crawler. Obviously, all these types belong to bigger structured data. There is no point to go into that. It's just to have an overview. And this is the JSON resume schema. And as you can see, it's different. It has some similarities. So for example, languages, here is optional, and here languages for some reason is required. It will always return a language. But one thing is, this language here is LinkedIn language, and here is JSON resume language. So that means that the types or the structure of the languages values are like different. So let's go with the first scenario of crawler result validation. So this is the entry point of the right branch when we are like generating the resume data. So as you can see here, I'm importing my LinkedIn schema validator. These are some helpers. No need to care about it. So this is the main entry. The first thing I'm asking if the file is there, is present. If it's not, then I'm asking for the credentials. This is just a CLI that will get me the username and then password. And then the second step, I'm sending the credentials to the crawler. This is the function that we'll call the crawler. And here I will get the LinkedIn data. Then I'm saving into a file. So at this point, I can read from the file that I just saved, and then I can validate it. So at this point, if for some reason the crawler returned invalid structure or a structure that I don't like expect, or the person manually changed the LinkedIn data, this will fail. Then at this point, I'm mapping, and then I'm saving. So here's another thing. There is no need to validate that here the JSON resume data is valid, because I did this mapping. I intentionally map it, and I know that my LinkedIn structure is valid, and therefore it shouldn't be a problem. So this is not considered an external source, for example. Then the other example is the resume content validation. And this happened in the file Gatsby config.js is the entry file for Gatsby when you can define your plugins. And yeah, more or less, what are you going to use in order to generate your website? So I'm starting just asking if, first of all, the resume JSON exists. If it doesn't, please run just the function of generate resume. And then after that, I'm requiring it and running the validation. And as you can see here, this is a catch. I'm importing my resume schema validator from the folder live. And the main reason of that is Gatsby config, sadly, is a JavaScript file. Therefore, the validator was generated in Tyscript. So I had to add another pre-built script into my pre-build, which transpile the source folder and put it inside this lib. So then I have access to the validation. But yeah, that's a little, just a little comment. And after that, I can send into my JSON resume theme of Gatsby, where I send the JSON. And I'm 100% sure that it has a proper structure. So after that, I decided to create a table like comparing all the approaches that we just saw. So on the left side, we have the different approaches, manual, using a library, and dynamic types. So let's go column by column. The first one is no additional syntax. And in the manual approach, this is correct. It's just vanilla TypeScript, vanilla JavaScript. The second one, you need to know regarding, like, depending on the library you're going to use, how you create these validations. For the dynamic type, it's actually pretty cool because what you're basically doing is just typing them. You're creating TypeScript definitions, and given that, you're having validations. So I will consider that as a check. validators and types out of sync. In the manual, yeah, they're totally out of sync. You need to manually type if statements asking for specific types. What is the worst thing ever is like what happens if you change your types. You need to go into your functions and change them manually. The good thing is the build step will fail, but still, it's a ton of work. For libraries, I decided to write down a question mark, and the reason of that is, yeah, there is some workarounds that you can make it work, and you can have them in sync. So that's why I decided to put a question mark. Dynamic types, as you are generating the validator from your types, they're always in sync. And especially if you run the pre-build script, like if you generate your validators every time you run your application, they will always be in sync. So that's a 100% yes. And the last thing is standardization. And I think this is a big one, because in the manual approach, let's go with the approach of, I don't know, checking for the length of an array or the length of a string. For example, is an email. So there's like thousands of ways to check if an email is valid. When you decided to use a library, normally they say, okay, here's how you can check if the email is valid, right? And that's great. That's great because it avoids a lot of confusion, avoids a lot of bugs for sure. So yeah, that's not covered in manual. You need to do it. You need to create your own standard inside your team. And then when you jump into a library, normally there is a way to do it. And this is very funny because dynamic types, given that they're using a library under the hood, they have this point cover. So yeah, overall, all these approaches, the one I really recommend of going through is dynamic types. So I just want to close with this phrase, which is validate more with doing less. Yeah, I thank you for listening. I hope you enjoyed the talk. And here you can find all the references that I use for the talk. And if there are any questions, I will be here to answer.
Thank you so much, Emma. That was really interesting, and it's a really novel approach where you validate more and write less. I think our audience will definitely have that in mind. We had one question at an earlier point during the stream where it was Volker Braun asked, is the syntax just normal JSON schema?
What do you mean by JSON schema?
I believe it was at the stage. There we go. Yeah. If we can go back a little bit.
This one or which one? The one that is generated?
Okay. I think. Okay. So Volker Braun just said he just had claps. So I'm assuming that we can resolve this after in the chat. You can feel free to hop on the chat. And we have also another one. Racelio Diak. Hi, thanks a lot for the talk, Mano.
Okay, you're welcome.
What about optional chaining defined in TypeScript to prevent undefined?
Yeah, you can do that. I mean, it's a way, but I don't think it will solve the problem of validating. Like optional chaining will allow you to just avoid your program from exploding, but eventually there is one point that you need to add an if statement at any point of in your program. So yeah, it's a way, but I recommend this approach because it's so annoying when you are working a TypeScript project and you are saying, okay, this object is of a type, but in runtime, when you go to the object and you check the value of the object, it's not. So I think that this gives like developers like security that when you say that this is a specific type, it is really a specific type in runtime too, because I have previously validated. So yeah.
Thank you. And then we have another question when using from Sleeman TN. When using GraphQL, sometimes we don't return the whole object. Some properties will be missing in the case the validator will throw an error, right? How to work around around this?
Yeah. It's a tough question because I also work with GraphQL and Tyscript, and it's a tricky situation. Like sometimes I realize that your types might be quite tight to the GraphQL schema, and I know that there is some ways that you can extract the type definition from your GraphQL server. And in this case, if you're saying that, for example, there is a property that can be optional, but then inside that property, the ID, for example, is required, that will work because the initial property, let's say property A, is optional, which returns an object, right? But that object has an ID that is required, is going to be fine, because if your property A doesn't exist in the beginning, it won't check for the required ID.
Thank you for that. And we have, Emma, are you ready for one last question before we wrap up?
Yeah, sure.
Okay, so I don't know if you can see the screen. William Gomez is asking, do you think that a good PR for dynamic types would be to create a kind of migration system for validator generation?
Can you repeat that again, please?
Do you think that a good PR for dynamic types would be to create a kind of migration system for validator generation? I'm not so sure what he means here by a migration. I guess the question is migrating from what?
Yeah, exactly.
Okay, well, hopefully...
maybe if they're already using some kind of validation library, they can jump into this. I will say, for the people that I realize that this is a common problem in the front end, for example, that they're using just JavaScript tools, and like before they were using JavaScript to validate, and then they decided to move into TypeScript, and they have two different things running at the same time, and they need to maintain both things. So I will say, try this approach with just a few of them. The cool thing about this is you can run like let's go here. You can generate the validators using this, and just generate the ones that you really want to, and that's it. Obviously, you can always create a script that go through all your types and create validators for all the types, but I don't think you have to do it. Normally, there's specific types that you want to create validator from. So yeah, I would say just give it a try, and also the cool thing is, like, you can see the code that is generated, right? So if you're used to this syntax, you can easily read it.
Right. Cool. Thank you so much, Emma. It was lovely having you.